Section 1.4, Linear Inequalities in One Variable. Before we looked at linear equalities, in which case we used an equal sign to relate the two expressions. In linear inequalities, we use one of the following symbols to relate the two expressions, either a less than or equal to, greater than, or greater than or equal to. It's important to remember when solving linear inequalities that when you are multiplying or dividing by a negative number, you must flip the inequality sign. For example, if you have negative 2 is less than x, or let's rewrite this, negative x is less than 2, then we can multiply both sides by negative 1, and we get x is greater than negative 2. Let's look at some examples. Example 1, I want you to solve the following inequalities. You are given two examples here to work through. Try them on your own first. They're very similar to solving equalities. The only thing you do need to remember is when you need to flip that inequality sign. So pause your videos and resume when you're ready to check your solutions. With example A, we're going to simplify as much as possible first, so we're going to distribute and then combine like terms. So we have negative 2x plus 11 is less than or equal to negative 1x plus, or negative 1 plus x. We can add 2x to both sides, and we can also add 1 to both sides, which gives us 12 is less than or equal to 3x, which is the same as 3x is greater than or equal to 12. Divide by 3, we get x is greater than or equal to 4. Now I can leave this as an inequality. There we go. Or I can write this in interval notation, in which case we use 4, infinity, with square brackets around the 4 because of the greater than or equal to sign. And then I can also graph this. So I find the 4 on my number line. I'm going to actually put a bracket right there to indicate we do include the value 4. And then I'm going to thicken towards positive infinity. You could also, if you want to, draw the number line a little differently. You could draw your number line. There we go. Such that we use a closed dot at 4 to indicate that we include the value 4. And again, we thicken the line towards positive infinity. Well, let's look at example B. To get rid of my denominators, I'm going to multiply both sides by 4. On the left, it reduces with 2, and on the right side, it cancels out. So I'm left with 2 times 3 is 6, times the quantity a minus 2 is less than 5a. Distribute, I get 6a minus 12 is less than 5a. I'm going to subtract 5a from both sides and add 12 to both sides, so I get a is less than 12. So I have a is less than 12. In interval notation, this would be negative infinity, comma 12 with a rounded parentheses. And on my number line, I use a open rounded parentheses at 12 and thicken the line towards negative infinity. Or if you want to do it the other way, we use an open dot at 12 to indicate that we do not include the value of 12. And we thicken the other way. So this is all the correct solutions for the value of a.